So here's Unit 3, which really is a continuation of the last section of Unit 2, where we're kind of looking at fractions. And so we started with just simplifying fractions, and some of them had a little bit of multiplication or division. Now we're going to look at adding and subtracting rational expressions. And so we've done this before, we just haven't done it with variables. Okay, so my first problem right here, problem A, we've done problems like this before in Unit 1. And so we're just kind of reviewing, how do I add or subtract fractions? And so what you have to do is you have to have a common denominator. And if you have a common denominator, then you can bring it together as a single fraction, and you can see that right here. So if you have that common denominator, you just complete the operation with the numerators, whether it's addition or subtraction. So right here, this will become 1 plus 3 over my common denominator 8. 1 plus 3 is 4. 4 divided by 8, and then we can simplify that. They're both reducible by a factor of 4. So you divide the top and bottom by 4, and that gives us a 1 over 2. So 1/2 right there. And like I said, that should be a review, but now what we're going to do is we're going to throw in variables, and that can complicate things a little bit. We're not going to go too crazy here, but we need to at least kind of look at this topic. It can get very messy. For the most part, ours should not be too bad. Okay, so looking at 33 right here, so we already have that common denominator, so that's good. So what we're going to have to do is we're going to have to go ahead and add the numerators together. So I'm going to go ahead and write that out. So we're going to have a 4x plus 1, and then we're going to add 8x plus 9 to that, and then it's all over my common denominator, 6x plus 5. Now, don't start trying to cancel anything out, okay? If you can cancel anything out, it will happen at the very end of this, okay? So let's see. What you want to do is combine your like terms on top. So I've got 4x plus 8x on top right here. That's going to give us a 12x. And then I've got a plus 1 and a plus 9. So that combines to plus 10 all over my 6x plus 5. And that 6x plus 5, the only way that's going to cancel out is if I have 6x plus 5 on top, which I don't currently. But what I want you to notice is that the top is factorable. Once I combine my like terms, if you look at it right now, they don't have anything in common to factor. But once I combine my like terms, you can notice that 12x plus 10 both are divisible by a factor of 2. So that's what I'm going to do. I'm going to factor out a 2 on top. And so when I do that, that will turn that 12x to a 6x, and then that plus 10 to a plus 5. And then what you'll notice is that now I do have some common factors that I can cancel out. And so what's going to happen here is basically these cancel. What happens is they basically reduce down to 1. So it turns into a 1 over 1. So I'm left with 2 times 1 over 1. And so this whole thing just reduces down to the number 2. So that whole thing, if you look back at 33, that whole thing just reduced down to the number 2. That's kind of interesting. So there are some restricted values. You're not going to have to worry about those. But if you plug anything else in that's not the restricted value, it would always simplify to a 2. That's kind of interesting, looking at the original problem. So like if you were to let x equal 5 or 10 or -7, and you do all the work, it will turn out to be a 2. Just want to point that out. Okay, let's look at 37. The only difference between 37 and the previous ones, I have a subtraction right there. So you're going to have to be a little careful here. I do have a common denominator already, so I'm ready to go. So I'm going to have a 4x minus 10, and then I have to subtract. Now this is where it's a little tricky. It's a little different. You need to put the x minus 4 in parentheses, because you are going to have to distribute that subtraction sign here in just a moment. So that's what we'll do next. So that subtraction, you don't want it to only go to x. It has to go to both of these right here, okay? So let's go ahead and clean that up. So we're left with 4x minus 10 minus x, and then that will become a plus 4 right there, all over x minus 2. And then let's see, we've got a, oops, different color, trying to color, oh, keeps doing that. All right, let's see, try purple. Let's see, so we have 4x minus 1x. Okay, so you had 4, take away an x. That will leave us with, let's see, 3x. And then, let's see, we had a minus 10x and a plus 4, so that should give us a minus 6. And then all over x minus 2. Okay, and this looks like it'll probably turn out pretty similar to the one up above, because what you'll notice is on top I can factor out a 3, so I'll go ahead and do that. And that will leave me with x minus 2 all over x minus 2. And then we'll go ahead and cancel out the x minus 2's. And so that all is going to reduce down to just the number 3. So that was kind of interesting. Okay, so this particular book that I'm using, they seem to be simplifying pretty nice. Some other books I've used, they end up very messy. So I kind of, on purpose, am trying to pick ones that kind of work out nice, because we're not going to dive super deep into this. It's an important topic, and it will support us in college algebra, but it also really will support you in pre-cal when you're having to deal with a lot of these and simplifying your fractions and stuff. But we're really going to kind of do as much as we need to be successful for college algebra, and maybe give you a little bit for if you're going to move on to pre-cal. But anyways, let's move on. So the next part we're going to look at here, we're going to add and subtract, but what we're going to do here is we have to, it asks us to list the excluded values. And what you'll notice here is I don't have common denominators. But what I want to do real quick, I do need to go back real quick and talk about the restricted values, because I just looked at the homework, and it does, some of the questions, not all of them, but some of them will ask you for the restricted values. So if you remember, the restricted values are values that would cause you to divide by 0. If you look at my first example, A, you don't have to worry because there's not a variable in the denominator spot, so there's not a chance that you'll divide by 0. And so if you look at 33, though, you'll notice that I have 6x plus 5. Those are my denominators. And so what you want to do here, the question's also going to ask you to list any restricted values. And we've done this, we did this in the last section of Unit 2. What you do is you just take the denominator, set it equal to 0 if it contains a variable, and then just go ahead and solve it. And that would be the restricted value. So set it equal to 0 and solve it. So let's say I end up with 6x equals negative 5. And then I'm going to divide by 6 on both sides. So I get x equals negative 5 over 6. So that's actually the excluded value. So we're going to put it as the excluded value. So when you're doing your homework, you'll see what I'm talking about. It will ask you for your answer, but then it will also ask, were there any restricted values? On the first one, there wasn't, because there wasn't even a variable. And so you really just have to focus on the denominators. If there's a variable involved, you just take the denominator, set it equal to 0, and solve. So if you look at 37, you would take x minus 2, set that equal to 0. We'll go ahead and solve that. And so we'll get x equals 2. Now that's actually the restricted value, so I put a little line through the equals 2. So we don't want x to equal 2, because if you were to plug it in, you would have a 0 in the denominator spot, and that would not be good. Can't divide by 0. If you plug anything else in, it actually equals 3, and I kind of talked about that earlier about the previous question. So it's kind of interesting how that works out. But even though my answer came out to be 3, I also need to know that the original problem, 2, was off limits. If I plug in a 2, you're going to get undefined. Okay, so like I said, when I was looking at the homework, not all of them, but some of them do ask you for restricted values, so just look out for that. Okay, so back to this one. So we're adding and subtracting without like terms. Once again, we've done problems like this back in our very first unit. So I have a denominator of 3 and 5, so my LCD on this particular one is going to be 15. That's the smallest number that both of those would divide into evenly. So what I want to do now is somehow turn both of those into a 15. So I'm just going to adjust the ratio. So this first ratio, I'm going to multiply by 5 over 5. And the second one I'm going to multiply by 3 over 3, and that's going to adjust my ratio. So instead of having 2/3, now I'm going to have 10 over 15, but that's the same ratio. That's the same amount. Every 2 for every 3 is the same as 10 for every 15, right? That's the same ratio. And then right here, I'll multiply by 3 over 3, so I'll get plus 3 over 15. Once again, that 3 out of 15 is the same as 1 out of 5. Those ratios are the same. Now that I have my common denominator, I can go ahead and add the numerators together. So I end up with 13 over 15, and that is my answer. Okay, moving on. So looking at part B, right here, I do have a variable in the denominator spot. So I have to look at that and be like, man, what would make that equal 0? So what would make this equal 0? And so let's see, I'll divide by 2 on both sides. And so x equals 0 divided by 2 is still just 0. That's going to be my excluded value. So if they ask for that, there you go. There's the excluded value. X cannot equal 0. Give myself a little bit more space here. Okay, now I need to find the LCD, though, looking at this. And so this is where it gets a little tricky. We haven't done it before where there's a variable involved like this, okay? So you basically, let's look at the numbers first, okay? Ignore the variable for a second. So between 3 and 2, the smallest number that 3 and 2 both would divide into would be a 6, right? 3 divides into 6, and so does 2. Okay, now if there's any variables, those have to come with it, okay? And in this case, we have an x. So the LCD is going to be 6x. And so now what I'm asked to do is I have to turn those denominators into 6x. So whatever they're missing, you have to introduce on top and bottom. So let's see, that 3 needs to become a 6x. So I'm going to have to multiply the top and bottom by a 2x. I'm going to multiply the top and bottom by 2x. And that will give me an 8x over 6x. Okay, that's good. Okay, now I have to adjust the other one. I need that 2x to be a 6x also, so I can have that common denominator. So this one's going to get multiplied by just 3 over 3. Just 3 over 3, no x, okay? And so that'll become 9 over 6x. And so that was the whole idea here. I needed that common denominator. Now I have it. And so now I can go ahead and add the numerators together. So I have to keep them separate though, because they're not like terms. So 8x plus 9 all over 6x. Now, do not try to start canceling the 6 and the 8 and the x's, because this is dividing both of them. And don't do the same thing with the 9. It's either you reduce all 3 of them at the same time, or that's it, you're stuck. And so what I've done previously in the video prior to this one is I put parentheses around it to kind of remind myself it's either all or nothing. Whenever you have addition or subtraction, just put a parentheses around it. It's either this whole thing cancels out or nothing cancels out, okay? So nothing's going to reduce here, okay? The only thing you could do, and I wouldn't recommend doing this, but you could if you really want to, you could break it, because 6x is divided into both of them, you could break it up like this, 9 over 6x, and then you could reduce each one individually right here. But what will happen is, to be honest, you just went right back to your previous step, and then you'd go back to reducing it to where you were, okay? So we'll go ahead and we want to leave it like that. We pretty much would consider it more simplified if we can write it as a single fraction instead of 2 fractions like we had up at the very beginning. Okay, looking at C, let's see, we have 5. I'm going to put that over 1 plus 2 over x. If I have 1's a fraction, I like to make them both fractions, even if it's just a 1 right there. So I do have a denominator with the variable. It's just x, so x cannot equal 0. So that's going to be my excluded value, because if I let x equal 0, I'd get 2 divided by 0, and that would be a problem. Okay, so on this one's not too bad as far as my LCD, because that x hasn't understood 1 in front, so they both have a 1. Okay, so it's going to be a 1. but then this one has an x, that one doesn't. So they're going to have to both have an x in order to be to have common denominators. So the 2 over x is already done. That one's good. Now the 5 over 1, what I'm going to do here is I'm going to multiply it by an x over an x, just like that. Now x times 5, that's going to be 5x, and then 1 times x is just x, and then I have plus 2 over x, like that. And then now that I have my common denominator, I can go ahead and add the numerators together. So that'll be a 5x plus 2 all over x, and there we are. Okay, all right, moving on. So I have 2 more slides to go, so what I'm going to do is I'm going to go ahead and stop this one for part 1, and I'll make a separate video to complete these last 2 pages.